Okay, this is just notation. There are a lot of different ways that we can write out a derivative. The most common, the way we're going to use most often during this semester is what we call prime notation. That's what I've been using so far, writing out f prime of x. This is called Leibniz notation, where we use what are called differentials. Remember, a derivative is a change in y per change in x. And what we're doing when we take a derivative, so f prime of x is literally, by definition, the limit as delta x approaches 0 of delta y over delta x. When we use that h definition, where the limit of h goes to 0, h is just delta x. So it's just a bunch of slopes of secant lines where our delta x is getting smaller and smaller until we get a tangent line. So we want to write something that kind of looks like delta y over delta x. And what we do is we say in the limit as delta x goes to 0, these deltas become d's. So we will write this as dy dx. Now these d's, this is not a fraction. The derivative is not a fraction. That's not dy divided by dx. This is just notation. This means the derivative of the function y with respect to x. This says x is your independent variable. This says y is what you were calling your dependent variable. And this says you've taken the derivative of y with respect to x. And another way of writing that is to say f prime. Sometimes we'll just say y prime. Sometimes we'll say the derivative with respect to x of my function f. These all mean the same thing. They're just different ways of writing it out. This one is the most explicit. And these two say the same thing. Leibniz notation is probably the best because it explicitly tells you what your variables are. Students sometimes get used to this one, and then if we throw in a problem where our variables are t and t for time and r for distance, they get confused because they don't know what to take the derivative with respect to. So I'll be using a lot of Leibniz notation here. Now I want to point out later on, we're going to be doing a lot of derivatives with respect to time. So let's say, for example, the x is some function of time. And maybe y might be some function of time. Like if you throw a baseball, then the linear position of that baseball will depend on time. And so will the height of the baseball. So if you're doing a physics problem, a projectile motion problem, you'll have these two functions. Well, in a physics class, we take the derivative with respect to time so often that we've developed different notation for that. So instead of saying x prime of t in a physics class, you'll write x dot. And that means the derivative with respect to time. And similarly, y prime of t in a physics class, you'll call y dot. Dot always means derivative with respect to time.